Here's the fourth video on our Test 1 review. Here we're going to practice using superposition to find the output voltage in an op-amp circuit. So if you want to pause the video and actually work this problem first and then come back and see the solution, you're encouraged to do that. So here we go. What we're going to do is we're going to first turn off all the sources except for the 1 volt source. So when I cross this out, this current source, it goes to 0, or an open. Cross this current source out, 3 amps, it's going to go to an open circuit. All right, and what I'm left with is 5 ohms here. And I notice that I have a 3 ohm in parallel with a 1 volt, but that doesn't matter. Okay, so this don't care. So what I have is 1 volt feeding 5 ohms, and I have a feedback resistance of 5 ohms. So I have a VO prime, we'll call it, that is going to be equal to, by inspection, minus 5 over 5 times 1, or minus 1 volt. Okay, let me get rid of this. Now, we're ready to turn off our second source, or apply our second source. So now when we turn this off, what happens? The 1 volt source gets turned off. It becomes a short. I should put that as short there, not a cross it out. Okay. The 2 amp source is on. 3 amp source is off. So what do we have? Again, the 3 ohms on the left does nothing. What we really have is we have a 1 or 2 amp source in parallel with 1 ohm, okay, and then it goes to a 4 ohm. Now I'd like to replace this 2 amp and 1 ohm with a source transformation, which would be 2 amps times 1 ohm, or 2 volts, and then the resistance would again be 1 ohm. And that will go in series with the 4 ohms that I have for a total of 5. And again, we have a feedback resistance of 5. So we can write VO double prime is equal to minus 5 over 5 times 2 volts, or in other words, minus 2 volts. Okay, and then lastly, let's apply our 3 amp source. We'll short the 1 volt and we'll open the 2 amp. And now what we have, again, we have 5 ohms for our R1, if you will, and 5 ohms for the feedback. And you might say, now what happens here? How does the 3 amp contribute to V out? So this one could trip you up. Let's redraw this. We've got 5 ohms in the feedback, and then 5 ohms grounded. But we're injecting 3 amps at the inverting input. So naturally we would think if current goes in here, we think, okay, well, that current has to flow through these resistors. Which ones does it go in? And we might think, okay, it's going to split equally because they're both 5 ohms. Well, the thing to remember is that this voltage here, V minus, is going to be equal to V plus, is going to be equal to 0 volts. Okay? So if this voltage here is 0 volts, and this voltage is 0 volts, then we'll have 0 amps flowing through here. So this turns out to be equal to, you might have to think about this one for a bit. It ends up not depending on that 1 plus 4 ohms. And all of the 3 amps flow out through the 5 ohm feedback resistor, such that we get a 15 volt drop and therefore VO triple prime is equal to minus 15 volts. And so now we can put it all together. VO is therefore equal to, what did we say, minus 1 plus minus 2 plus minus 15.